What is a mole?
Mole.
I'm not talking about that, and I'm not talking about the funny little critters. I'm talking about a mole in chemistry. And what a mole is just a quantity. And so in everyday life, we use a dozen to mean 12 things. So a dozen bagels is 12 bagels, a dozen eggs is 12 eggs, a dozen people is 12 people. So those things are just kind of everyday items. But then when we talk about a mole being a quantity of things in chemistry, well, it's a much larger number because the things we're talking about are very small. And so the things are typically going to be ions, atoms, molecules, particles, something like that. And we have this number of things, which is 6.022 times 10 to the 23rd. Now that number written out is this here. So it's a massive number. Now, it may seem arbitrary. Why do we use this number? And that all comes down to how the mole was defined. Now, this is Avogadro's number, not Avocado's number. It's Avogadro's number, named after our boy Avogadro. And so the reason that this number of things is the definition of a mole is due to how he found the number, which was, or how he defined it, which is the amount of carbon-12 atoms, the quantity of carbon-12 atoms in 12 grams of carbon-12. So in other words, one mole of carbon-12, which is 6.022 times 10 to the 23rd atoms of carbon-12, that's going to be equal to 12 grams. And so if you saw my video on isotopes, this number here, the 12 on the top left of the carbon, that's its mass number. And so in other words, this carbon atom weighs 12 atomic mass units. Now, if we have Avogadro's number of this atom that weighs 12 atomic mass units, then the total weight is 12 grams. So it's really convenient to use a mole because it allows us to use the molar mass of a compound or the atomic mass of an element as its weight in grams if we have a mole of that substance. Okay? So let's get into an example now on how we use Avogadro's number and the definition of a mole when we are dealing with questions and on an exam, right? So before we get to that, guys, if these videos help you out, please give a like, follow, share, save it for later so you can review again. And if you'd like to go further, please check out my links so you can patronize me over there. That helps me to continue making these videos for free. So now let's do an example problem. And let's say we have a question and they are asking us how many atoms are in a certain number of moles. So let's say we're given 0.231 moles of lithium, and they're asking us how many atoms that is. So when we're asked for a quantity of things, and again, those things are typically going to be atoms, molecules, ions, particles, something like that, we're going to be thinking of Avogadro's number and the definition of a mole. So in other words, if I said, how many eggs are in 3 dozen? Well, you need to know the relationship that 1 dozen is 12 things, right? In this case, it's going to be a dozen eggs is 12 eggs. So whenever you're thinking of quantity, you're thinking the mole relationship and Avogadro's number, okay? So the definition of a mole. So let's do it. Now, I taught you this technique of dimensional analysis in my dimensional analysis / unit conversions video. So we're going to be using that technique in many of the math problems in this course. So check that out if you haven't, but let's go ahead and do it now. So like I said last time, we're going to take the given information and that goes to the left. So we have 0.231 moles of lithium. And then we're going to set up a parenthesis that goes across like 2 lines in your notebook. Put our fraction bar here. And now we look at the relationship. We look at this and we say, okay, 1 mole of something, in this case it's going to be lithium, is equal to this many, and then the things in this case are atoms of lithium. So we want to cancel moles, so this side is going to go in the bottom, and I'm going to write out 1 mole of lithium, and what it's equal to goes on the top. So 6.022 times 10 to the 23rd atoms, I'm getting a little sloppy here, of lithium. All right, so now we just punch that into our calculator. And I also reviewed this, I think, in that same video on unit conversions. So we're just going to punch this in, 0.231 times 6.022, and then that double capital E means times 10 to the. So I'm typing in 6.022, the capital E, 23. So this is power on the 10. And we get as our answer, let me write that just down over here, we get 1.391, and then there's more digits, times 10 to the 23rd. We always have to use the correct number of significant figures. So we want to use the 3 that we have here, 1, 2, 3, and we're just going to round this to 1.39 times 10 to the 23rd, and that's atoms of lithium. It's hard to write down there at the bottom of the board. And that's it. All right, guys? So now I'm going to ask you another question, and I want you to comment the answer down below, and I'm going to have you do this in reverse. So let's say that I gave you something like, 8. Wow, that is a bad 8. Let's try that again. Let's do 8.04 times 10 to the 25th atoms. And let's just keep it with lithium. And I want to know, how many moles is that? All right, guys? So comment that answer. And I'm going to be getting into conversions with mass in the next video. And so we're going to be talking about molar mass there. All right, guys? So again, please support the channel, like, follow, save, all that. Check out my links to patronize me, and I'll see you in the next one.